Yo, yo, yo. Yo, yo, yo. 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 Hey, guys. We're going to talk about operations with scientific notation in this video. So if you have not watched 2.2/2.3, which is just talking about what scientific notation is, please make sure you go and watch that now. Watch that first, because I expect that you know how to move numbers into scientific notation or out of scientific notation during this video. So what we're going to do is we're just going to focus on adding and subtracting numbers that are in scientific notation. Now, I'm going to show you guys a shortcut on how to do this, because we could always, when in doubt, you could always change these three numbers into standard notation. So I always have the option of going over 6 times, so that's going to be 4, 2, 1, 2, 3, 4, 5. So this is 4,200,000. I can change it to standard notation. Change this one to 225,000, and then change this one as well. And then I can add these numbers together. This 100% works, and then I would have to rewrite my answer back into scientific notation. So this is always an option when in doubt. However, instead, let's show you a shortcut so you don't have to go into standard notation. Because if I wanted to, I could do 4,200,000 plus 225,000 plus 2,800,000. Add them all up, go back to scientific notation. That would work. But what else I could do is I could take this shortcut. When adding numbers in scientific and subtracting, what we have to do is we have to make sure that the power is the same. If the power is the same, it's actually really, really simple. We would just add them up and keep the power. If they're not the same, we have to move the decimal over 1 time or 2 times so that they are the same power. Here's what I mean by that. And actually, let's kind of go back to look at why this is what it is, now that I think about it. So when I converted these to standard notation, I had 4,200,000, 2,800,000. Well, because this is to the 6th power and to the 6th power, if I were to line these up on top of one another, they line up because they have the exact same amount of digits, right? When they're the same power, that means they have the same amount of digits. So therefore, they automatically line up. So really, all I'm doing is 4 and 2, and I'm adding that with 2 and 8. So that's 1, and that's 7. And then I just bring down all these other zeros. So 4.2 times 10 to the 6 and 2.8 times 10 to the 6, if I were to combine these, the digits are already lined up. And I would have gotten 7 million when I added them. Or 7 times 10 to the 6th power. Because I can always go 1, 2, 3, 4, 5, 6. That's 7 times 10 to the 6th power. So when the exponent's the same, instead of going into standard notation and adding them, I can actually just add the numbers in the front. So I could have done 4.2 plus 2.8 is 7.0. So I know that's going to be 7.0, and then I would have kept my exponent times 10 to the 6th power. Now, the problem is this one to the 5th power, I can't just line these ones up because this has less, this does not have the same amount of, this isn't the same place value. So I cannot just line up 2.25 with 4.2 and add it because it's not the same exponent. So what I want to do is I can move it over 1 to the left to go further away from where it's going to end up. And if I move it to the left, I get to add 1 here to make it a 6. So I understand that when I do that, I'm no longer in scientific notation, but for the purpose of this problem, I can add these up, and then therefore I'm going to have my final answer. So, quick recap. So what we do is we want to add or subtract numbers in scientific notation. We have to have the same exponent in order to do so. If they have the same exponent, we just add the decimal on the front. So I did 4.2 plus 2.8 is 7.0. Now this one in the middle here does not have the same exponent. So if I want to make it the same, I can, but that means because 2.25 means I have to move it to the right 5 times. If I move it once to the left, Now it becomes 10 to the 6th power because I'm adding 1 to here because I moved a 1 over. So what I did is I changed it from here to here. And the reason why I did that, these actually represent the same number. If I go over to the right 6 times, I'm still going to get 225,000. If I go over to the right 5 times, I'm still going to get 225,000. These are actually the same number. The reason why I did that, though, was because now this is to the 6th power, and it lines up the place values. Because what it does is it basically shifts everything over so that when I line it up, it's going to line up as 0, 2, 2, 5, 0, 0, 0. It's almost like adding the 0 here, so all my digits lined up accordingly. The correct place values line up. So now that I have the same power, I can add this 0.225 to the 7 that I already got. So, going back here, I'm going to erase all of this here. So I know that this is 0.225 times 10 to the 6th. I moved it 1 further away from where it needs to be, so that's why I had to add 1 here. So now what I can do, because they all have the same power, I get to add just my decimals. And then I know my answer is going to be times 10 to the 6th power, because this stays the same. So we know 4.2 plus 2.8 is 7, and then when I add that with the 0.225, I get 7.225. So all I did was add these values. I added 4.2, 0.225, and 2.8, and that gave me this. And then I kept my power the same. The same rule does apply for subtraction. So add up your numbers once they're the same exponent, and then you're done. Go ahead and do this one on your own. Do the second one on your own. So the cool part about this one is they're all times 10 to the 2nd power. So that means I just get to add all of these up. And I know my answer is still going to be times 10 to the 2nd power. 1.25 plus 3.25 plus 0.5. And now I just get to add all these up. All right, that's going to give me 0, 1, 0, 1. Because that's 10, I'm sorry. So 5 plus 5 is 10. There's my 1. This is 10. There's my 1. There's a 5. Bring my decimal down. So this is 5 times 10 to the 2nd power, and I'm done. One thing we always want to make sure is once we do add numbers or subtract numbers in scientific notation, make sure our answer is finally in scientific notation. If it's not, that's when we're going to have to change it back to scientific notation, and I'm sure I'll show you an example of that here in just a little bit. So this table below shows the population of the 3 largest countries in North America. So you have the United States, Canada, and Mexico. Those are the 3 largest countries in North America. Find the total population of these countries. So what I want to do is I want to figure out how many people live between these 3 countries. So I have to add these 3 values together. So because I'm adding these 3, what I need to see is, do I have the same exponent? Do I have to the 8th power, to the 7th power, to the 8th power? So I want to change everything to be to the 8th power, because that means I only have to change this value right here. Because once they're all to the 8th power, I just add my numbers and I'm done. So the way I change this, because if I go 7 times to the right, that's going to give me my value. So if I want to add 1 to that, I got to go once the opposite direction, to the left. So this becomes 0.338 times 10 to the 8th power. Because think about it, if I move this once over to the right, now I'm 7 away and I'm back at the same exact thing. Now that I've done that, I can add up all of these numbers, and then my final answer is going to be in scientific notation. So I get to add 3.1, 0.338, and 1.1. So I just get to go off to the side, line up my decimals, and add these up. But notice how you have to line up your decimals. If you need to add your 0 placeholders, add your zeros. And then it's just a quick addition problem. So I get 4.538, but I also cannot forget that this is times 10 to the 8th power. I kept the exponent the same, so I'm done. Subtraction is the same thing. We have to have them all be in the same exact power, and then we're able to subtract. So this first one here, I have a 3, and a 2. So I need to change this to 3. So I'm going to move my decimal over once. So this is really 0.1 times 10 to the third. So I'm doing 8.5 minus 5.3. I'm going to do that subtraction real quick. And I got 3.2. So I just did 8.5 minus 5.3. And that gives me 3.2. And then I got to subtract 0.1 from 3.2 because now I got to do this one. And that's 3.1. And that's again times 10 to the third power. Now this third one, try it on your own, or this last one, try this one. And you have a lot of them that are different. So what we're going to need to do is you're going to need to change the exponents so that they are the same. Change the smaller ones to the larger one. That'll help. So pause it if you haven't done so. Try it on your own. So this is 2.6. So it's going to become 0.26. I'm going to rewrite the whole thing so I don't get confused. I just had to move it over once. This one I got to move over 3 times because if I move it over once, it's just going to add 1, which is going to make it 10 to the third. I got to move it over 3 times. So that's 1, 2, 3 because I'm moving it 3 away to make it 0.0019 times 10 to the 5th power. And the reason why that works is these two numbers are the exact same thing. This, if I go 5 to the right and 2 to the right, I'm going to end up in the same spot. They're the exact same thing, but I wanted to do it that way so that now I am able to subtract these because now they have the same exponent. So I have to do 6.2 minus 0.26. It's going to give me 5.94. I just did quick mental math. So 6.2 minus 0.26 is 5.94. And now I got to subtract 0.0019 from that. So again, if I need to go off to the side, I have 5.94. 0.0019 is what I'm subtracting. This is going to require some borrowing. So that's going to become a 3, 9, 10. So 10 minus 9 is 1. 9 minus 1 is 8. And then I just have 3, 9, 5. So my final answer is 5.9381 times 10 to the 5th power. Okay. And that's it. Okay, so biggest thing is your exponents have to be the same. Your exponents have to be the same. So what I want you guys to do actually, in your key terms, we're going to write down that rule. To add and subtract the exponent must be the same. So let's write down our key terms. And then we have our last problem that we can try here. Because the last problem is how many more people live in France than in Australia? So how many more people live in France than in Australia? So that just means that we have to do a subtraction problem to figure out the difference. Luckily, they're both to the 7th power already. So that means I'm just doing 6.48 minus 2.15. I got 4.33. Oops. And I'm done. Okay. That's it. So for things to remember, I want you to write an example of moving the decimal over. So 2.4 times 10 to the 8th, and then maybe draw an arrow below it and say that's the same thing as 0.24 times 10 to the 9th. That's me adding 1 because I'm moving it 1 further away from where it needs to go. Okay, get the independent practice done. If you have any questions, please let me know. Gradius out.